Okay, let's factor this one, please.
Yeah.
Yeah, they bought some pizza. I had a couple of slices of pizza just now.
Yummy.
Yeah. Let's try that one. Doing well here. Yeah, let's do that next. Let's see how the whiteboard is looking. Is it a little too early for the whiteboard? No, it is not. Taylor, Tawana Taylor, what happened? Taylor. Man, what happened to Taylor? All right, Stephanie is making good progress. Oh, wait a minute.
I'm done.
Finished, yeah. Huh. I think Stephanie's actually finished. Yes, yes, yes. Stephanie is a factoring whiz, everybody.
No, I'm not.
Now, Latrice. I can't tell if that's the old problem. It's similar to the old problem. Bakelu. That's okay. This is the new one, and that is very close, Bakelu. I'm gonna give you 90% on that one, Bakelu. Yeah. Freeman. That's the old one.
I'm coming.
Yeah.
I'm coming. Yes, that's the old one, Professor. Sorry. So it'll be. Go ahead.
Taylor, are you back? Taylor? Taylor, you're not back? I don't think Taylor's back. Okay, well. Mm. Okay, ready, Freeman? Okay, maybe not yet. That's fine.
I'm ready to write it on the whiteboard.
All right, good stuff. Oh, Bakelu, now we are 100% Bakelu. Wait a minute, take that back. Oh, no, no, no.
Okay,
Wait,
thank
no, 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 wait, no, no. No, Bakelu. That's it. 100% Bakelu. Thank you.
Okay, thank you, Professor.
Freeman. No, wait. That's Carol. Wait a minute, Carol. Wait.
That was an old one, Professor. I'm about to write the new one now.
Yes, okay.
Yeah.
Get confused for just a second there. Got it.
No, I'm sorry.
Old one. That was the old one. Taylor is, I'm not sure. Okay, Brian's coming. Thank you. So Brian, send me a text when you want to do a makeup, all right? Give me two options. I can make one of the two and more in all likelihood. Okay, Carol, that's looking good
Okay.
so far. And I'm assuming that's a parentheses there, Brian. So that's good. That's good. That's good, Carol. Okay. That's good, Brian. Carol, what is with you and these signs?
I know. I keep getting mixed up. I think that's a
Yeah.
minor. Oh, now it's in bold. I'm sorry.
Thank you.
Okay.
Jeez.
Okay. Okay.
All right. We're about to do this, Freeman. So when we have numbers, three numbers, usually it better start with the smallest number. Like you could say 6 times 1. So 6 might be the number we're looking for. So this is 6 and 2. This is 6 and 4. All right. Then we look at.
I did 3. Sorry.
So yeah, this would be a good idea. When you have 3 numbers, start with the smallest number. Now we'll look at the letters. X second, X to the second, X to the third. So this X to the first, this is our smallest X. So we start with the smallest X, leaving it as is. X squared, we're going to make X times X. And the X to the third, we're going to make X squared times X. Looking at the Y's, Y to the first, Y to the first, this is Y to the second. So we got to break down the Y's with a Y times another Y. So we've broken everything down. So what's in common with all of these, starting with the number? There's a 6 here and here and here. So 6 is the first number that I write. I look at the variables. There's an X here, there's 1X here, and there's 1X here. So I write the X as part of my greatest common factor. Looking at the Y's, there's a Y to the first here, Y to the first here, Y to the first here. So I bring out one of the Y's. So this is my greatest common factor, leaving me with the leftovers. Plus sign, minus sign. This okay, Taylor? All right, okay. I may need a little bit more room. I just probably should have erased the parentheses. So what's the first thing? What's left over here? You see what's left over, Freeman? What's left over?
Yes. 2x.
And a y.
Y. Yeah.
Whatever's left over, 2xy. That's what goes here. What's left over here?
The 1. XY.
No, just the one. These are
Oh,
all
I'm
crossed out.
sorry. It was a little blurry. They canceled out. Okay. Yeah. Just the 1.
Canceled out because we factored them out over here. And what's left? Left over here?
4x squared.
4x squared. When it's written as a multiplication problem, there is your answer. And again, 6 and 2 is 12. X and x is x squared. Y and y is y squared. 6xy times 1, 6xy. And again, 6 and 4 is 24. X squared is x cubed. And the y here, we multiply that puts the y there. Man, I lost track of what number we're on. We're on number.
That was number 8, Professor. So
Okay.
this should be 9.
That was number 9.
That was number 9.
Yeah, we on 10.
Oh.
Damn.
Oh, dang.
Okay.
Mm.
Good. Okay, so we're halfway there.
Oh, yeah, y'all right.
So let's try this one. Now I'm gonna do. We're gonna do this one together. You want to see this?
Mm-hmm.
Yes.
How many terms we have here?
4.
4
4.
terms. We haven't had one with 4 terms before. So when we have 4 terms, we're going to do something a little different. We're going to factor by grouping. And when we factor by grouping, what we're going to look for is a situation where we have a pair of twins. We have a pair of twins. You're going to put the twins out, and the leftovers go another set of parentheses. So we're looking to create a situation like this. Does everybody see this?
Mm-hmm.
So this is our objective, to find a pair of twins. And we're going to do this by factoring by grouping. So when we factor by grouping, what we're going to do is we are going to cut this in half.
Mhm.
And we're going to factor this half. And then we're going to factor this half.
Okay.
Okay? So let's cover that up. So let's factor these two. When we have numbers, let's deal with the smallest number. 8 times 1. So this has to be
8 times 5.
8 times 5. When we're dealing with the letters, we first write down the
X.
exponent with the smallest, the
Square.
x squared here. So now we gotta break this x to the third down to x squared
X squared times X.
times x. So we're gonna factor these two. So what is a common number?
8.
The 8. So I use the 8 here and I use the 8 here. What other things do they have in common?
X squared.
X squared. There's x squared here and there was x squared here. So inside, this parentheses are the leftovers. What are my leftovers here?
5X.
5x, good. Those are leftovers.
And 1.
Minus sign
1.
and the 1. So that takes care of the first two. Got to do the same thing for the second two. And we have to be mindful of this negative sign. We'll talk about that very soon. So this 5.
5 times 1.
So this
5 times.
just 25.
5 times 5.
5 times 5. Now there's an x here and there's no x here, right?
Mm-hmm.
Okay. So now let's factor these together. Now we have to include this minus sign. So
Can you just bring it down behind the 5X? Take away 1.
okay, yes. So I'm bringing down this negative, this negative. I'm bringing this negative straight down, and they both have a 5.
Mhm.
So I'm going to cross out this 5. I'm going to cross out this 5. I brought this minus sign down here, and these two 5s I factored out. Is there anything else in common with these?
No.
So that means now I'm putting in the parentheses.
5X.
So what goes in here is the leftovers, 5x.
Plus 1.
That's 1.
Now, here's where we have to be careful because this is positive here, correct?
Mhm.
Mm-hmm.
Mm-hmm.
But this is a negative 5.
Oh, okay.
So that
Would be
means
minus.
this has to be a
So it'd be
minus
-1.
because this negative 5 with this -1 will get this positive 5.
Oh, yeah. Mm-hmm.
So we have a negative sign, just bring the negative sign down. And then we just factor this as we would normally, but you got to make sure that when you multiply these last terms together here, that that it comes out positive. Okay.
So we end up with
Yes.
twins again.
Say that again, Stephanie.
So we end up with twins.
So these are twins. So just to make life easier, I'm going to write these twins first. 5x minus 1. And this parentheses are the leftovers. So this 8x squared is a leftover. And what else?
Minus.
Minus 5.
And
Minus
5.
5. Minus 5.
So that's how you're going to get that +5. back up the top, right?
That's right. Exactly. That's how you get this positive 5 at the top. So this is factoring by grouping. We'll be doing this most of the evening. Let's try another one. Example 11. When you see 4 terms, you want to factor by grouping. Okay, give yourselves a few minutes to try this, and let's put the answer on the whiteboard. If you are able to get that far, let's try it. Let's try it. Let's try it. Just try your best. Get as far as you can. Give yourselves a few minutes. We are almost finished with the course. Do a little more refactoring. We'll solve an equation with factoring, and then that'll be it. That sounds encouraging, Freeman, right?
Yes. I'm gonna miss you guys so much.
You know what? I must confess, I did not check Taylor. You remember what Taylor said last class, everybody?
Oh, about
Oh,
her homework.
You did not have to check my stuff. I did not do it.
oh man, Taylor, I
I
ain't
ain't, nope, I ain't do it. I ain't do it. I ain't even gonna lie, I ain't do it.
I think I messed with you, Taylor.
hey,
I was sick. I really ain't do it. I was sick.
Oh,
I ain't do it.
Oh.
oh, okay. Now you were okay.
No, I really was sick. I had sickle cell. I was really sick.
All
Oh,
right. See,
Aw.
I just wanted to remind you what you told the whole class.
I know. I was sick. I was getting an infusion. I was sick.
All right.
she gonna do it, Professor.
Aw.
I'm glad you're better right
Get there.
now, Taylor.
I'm glad I'm better too, because I could have been in the hospital for days.
Wow.
Yeah.
Mm.
Take care of patients, smaller patients. But that when I worked at
That would have been a worse place to be.
pediatric.
I was in there for
Lord.
Christmas and New Year. It was so bad.
Oh wow. Okay.
8 months
Anybody
of near
with
crisis.
Mm.
See. Or
we're gonna go as far
I'm
as we
trying,
can.
Professor. Hold on.
So it's 7:38. We'll go over this at 7:40, but once you get as far as you can. As far as we can, yes.
How much, little professor?
I'm looking at it right now. Your third line. Are you
Just to
multiplying it
check.
back out? Well, okay, before you check it, I need you to pull the twins out. You know how you pull the twins out?
Oh, okay.
Let's take care of those twins. Bakello, I don't see anything. Hello? Hello.
I am trying, Professor. It is a little
Oh, okay.
sorry. Yeah.
I kind of quiet.
comment,
There.
Professor.
Wasn't sure, Hello. Brian's gotten quiet as well. Carol, what's happening?
Still here. I'm trying to get these twins together.
Yeah, get the twins. We are advocates of the twins. We like the twins.
Mhm.
Hey, I see some twins, Freeman.
No comment, Professor.
Now I'm trying to see about. Oh, okay. I got you, Stephanie. That is. You should put both of those in parentheses. That's all, Stephanie.
Oh, okay. The two bottom.
Yes. Not done. Okay, I got you, Brian. All right. So I see something from Brian, from Latrice, from Bakelu, something from Stephanie, something from Freeman. So whose name did I not call?
Taylor, as usual. Carol.
And Carol, I think that was the other one there.
Okay.
Let's looking, Professor.
Freeman, I believe that is a 100.
All right, Professor. You see mine on the board yet?
I do, and that is a 100. Taylor, 100 Taylor. 100 for Taylor, Freeman, Stephanie.
I don't know, Professor. Shit.
I am then also Professor.
Something is a little off of your second. Wait, is that a 1 in front of the R squared or a 2, Bakelu?
This is one.
That's a 1? Okay.
Yes.
All right.
I don't know,
If you
Professor.
can erase the
I
ones, that'll make it look a little better. And
Okay.
that is very nice, Carol. Yes. Okay.
Okay.
Wow, that's so good. Just to be sure, we'll go ahead and do this one all together, but I think everybody did a nice job, pretty much. So 4 terms, split it, right?
Mm-hmm.
So this is 3 times 1. This is 3 times 2. So there's really no, I'm sorry,
Ooh, I was ready to say, oh, Lord.
2 times 1. So besides 1, there's no
Wait a minute.
common here. Look at the R's. You got R squared. That's the smallest R.
Mhm.
And over here we have R squared times R. So what is in common? If you want to put the 1, you can.
R squared.
And then they both have R squared.
R square.
So they both have R squared. So I can cross those out. And we both use the 1. So the leftovers is a 3R minus 2. That look okay?
Yes.
Yes.
And I'm going to erase the 1. I don't like seeing the ones in front. It's not wrong, but it's just kind of awkward.
The homework does that too, Professor. It'll give you that, it'll mark it correct, but it'll tell you not to put it
Okay.
in front of the verb. Tell you. They suggest that you do it.
All right. So what's the largest number that goes into these? Both of
3.
these. 3 times 3, 3 times 2. So what we're going to do is going to bring down this minus sign, and they both have 3. So I'm going to put the 3 here, cross those out, and what's left over? What's left over is this 3r, and I see a 2 here. And
Mhm.
it's going to be positive, so this has to be negative here.
Right.
Yes.
That gives us our beloved twins. So we write the twins 3r minus 2. And the leftovers is the r squared and the minus 3. That is so good. That is very nice. Question on that, Latrice? How we doing with that, Latrice?
No, it's fine. I see where I had messed up on the second portion that we had did. I had only put 1 3. I only did the -3 and not the 3r. If that
Oh,
makes sense.
okay.
Yes, yeah, I see where I messed up.
Very good. So let's kick it up another notch. Let's kick it up another notch here. So let's do example 12. Example 12. I'm gonna write this. All right. So this is a trinomial, right?
Mm-hmm.
3 terms. Please notice this. When the trinomial is written, we see x to the second power, x to the first power, and then the constant. Remember we had a name for this when it's written this way?
But a trinomial?
Yeah, but this is written in descending order.
Oh, okay.
The
2 to
highest,
the 1 to the none.
yes.
Yeah, it's descendant. We gotta write it in standard.
Okay, no. So whenever
Gotta get
you want it in descending order.
descendant order. Okay.
Yeah. And when you have a constant at the end like this, the way we're gonna factor this a little differently. We're gonna factor this. We're gonna factor using the AC method. The AC method. What the heck is the AC method? So that's what I want to show you. When you have a trinomial in descending order, this leading term, the 3 is your A, the 11 is your B, and the 6 is your C. So the way the AC method works is I think it's 3 steps. Let's count them up. Let's see. First, you're going to multiply A times C. And then you find a pair of numbers that multiplies to whatever AC equals and adds to B. And don't worry, we will do with example 12. We have time for 8 examples of this. And then we're going to rewrite into 4 terms. So it's going to be 4 steps. You write into 4 terms, and the 4-step factor by grouping.
Oh, wow.
And that's your AC method. So
Oh,
when you copy those 4 things down, we would try that right here for this one. So let me know we have those 4 steps.
Got it.
So I'm going to rewrite this problem on another sheet of paper. Example 12. Let me rewrite this. And you will definitely like how this works. Okay, so over here on the
What's the last
side, I'm going to do the AC method. I'm going to do that over here. Do the AC method on the side. So when I multiply A times C, I get 18.
Mhm.
First term, last term, I get 18. All right. So far, so good?
Yep.
So I'm going to find a pair of numbers that multiplies to 18 and it adds to the middle term, 11.
Hmm?
So let's write the pair of numbers. What multiplies to 18?
9 and 2.
We got 1 times 18. We got 2
9 times 2.
times 9. We got 3 times 6. Any one of these pairs add to 11?
9 and 2.
9 and 2. Okay, so far.
Mm-hmm.
All right. So so now we're going to rewrite this into 4 pairs. And we're going to use this middle term using the 2 and the 9. So watch this. First term stays the same. And I'm going to change this 11. We'll make it 2x plus 9x. And then I'll put the 6 at the end. So the middle term you expand using whatever pair you found. So instead of 11, I found a pair of numbers, the 2 and the 9. So I put 2x 9 next to adds to 11. Now I have 4 terms. So I'm going to factor this by grouping. So I'm going to pause. I would like you all to factor that part by grouping. And put that on the whiteboard. Let's see how we do. I think we're going to do just fine, just fine. So this is the first example of the AC method, where we factor by grouping. This works wonderfully for trinomials that are written in descending order.
Oh, wow.
Okay, Stephanie's looking nice. There we go, Stephanie. Now, Latrice, you don't need to put that 1 in front of the X. I mean, if you want to, that's fine. But like Freeman said, computer's going to ask you not to do that too many times. It just looks a little awkward. That's all. It's not wrong. It's not going to be marked wrong. So nice job with that, Stephanie. Latrice, that's nice. Waiting for, okay, but Kellu's getting there. Don't see Carol.
Look again, Professor.
Freeman. Oh, that's an old one.
I mean, that's an old one.
Taylor, how we doing there? Taylor? Now, Bukelu, you are not going to have that plus sign in between those two binomials. You hear that, Bukelu? Bukelu. Thank you.
Yes.
Okay. Now, do you understand why it's not there? Because that was part of the leftovers. That plus sign is in the other, is really in the other binomial.
Okay.
All right, that's good, Brian. So, Brian, Bukelu, Latrice, Stephanie.
I'm coming.
That sounds like Freeman there, right?
Yes.
They say it like that. Come on.
Yes. I'm coming.
You know what? I don't think you're going to get to 20 examples. And that's okay. But I'd like to get to 14, Freeman.
All right, Professor, I'm coming. Let me just give you what I got so far.
There you go.
Help.
Yeah.
Show you what I got because I'm not finished.
So, yeah, we got to do a couple more. We got to get used to the AC method. So we cut it in half here.
How we did it before, Professor?
Are you just skipping me, Professor? Okay.
Oh, that's Carol. Come on, Carol. I don't
It's
see
been
any.
up there. Waiting for
I
you to
see
say this.
I
Right.
see the original problem, Carol. What?
That's what I got.
The original problem? Anyway, look. All right.
Well, go ahead.
You see my.
Okay, Freeman, that's pretty good. Put a plus sign in front of that 3, and we can keep it going.
Okay.
So, okay, middle of the path. So right here, how do I factor these first two? What comes out?
The X.
1.
The X
X.
come out.
Okay. I'll forego the 1. What else?
Then you're gonna have 3x plus 2.
3x plus 2. You had that, Freeman, I think, right?
Yes, yes.
Okay.
So over here, plus sign between 3.
You what? Oh, 3. Okay, sorry.
What else?
3x plus 2.
3x plus 2. Because that gives you 9x. That gives you 6. And there's our beloved.
Oh, then they want twins again.
3x plus 2.
And x plus 3.
3.
Okay.
There we go. Let's go to example 13 because I'm trying to get a few more in here just to really get used to the AC method. And here's a great one. 10x squared 27x plus 5. 10x squared minus 27x plus 5. Shall we do this together? Or you want to try yourself for a few minutes?
Try it out.
Good night, Victoria.
Good night, Miss Victoria. Yeah, let's give yourselves 4 minutes. And 1 o'clock tomorrow is good, Stephanie.
Yes.
And Brian, how's 1 o'clock tomorrow sound for you?
That sounds good to me.
All right. So just meet me in the Zoom room. If anything comes up, just send me a text. Something changes. It's not a problem. Oops. Go. The AC method. There's only one more thing that you're going to, well, let's say 2 more little things to you know. Okay, I'm about to say, what's taking Stephanie? What's Stephanie's delay?
I
here?
had to figure it out with my paper first.
Sure.
That 27 got me discombobulated.
Temporarily.
Oh.
I'm gonna put what I think. I don't know.
Really?
Yeah, I mean, them signs.
Ah, the signs. I'm telling you, that's something else. Isn't that, Freeman?
Yes.
They just don't go away.
It's me every time.
They
No.
never go away. Nope, they don't go away. Oh, wait a minute. Well, okay, Stephanie, I know it's 8:04. Maybe we should do this one together.
Mm-hmm.
Yeah. Yes.
We did, but not finishing.
Okay. So here's the deal. When you multiply the A and the C term together, what do we get?
Is 15, 50?
We get 50,
50.
right?
Okay.
Right? So I need a pair that multiply to 50 and add to what number?
11.
To what
7.
number?
27.
-27.
Negative 27.
Negative
Oh.
20.
And
Oh,
negative
okay.
27.
So I skipped the part.
Oh, dang. Okay.
Got to multiply
That's a good idea.
to the 50
Oh.
and add to minus 27. So let's think about a pair
Oh,
of numbers. It's got to add to minus. So we got
25 and 2.
1 times 50, 25 times 2. Now,
yes.
if they add to negative 27 and multiplies to positive 50, both of these signs have to be
Gotta
what?
be negative.
Both of these signs
Negative.
have to be negative.
These signs do not go away.
So this minus 25 and minus 2, I'm going to put that here. So I'm going to rewrite. First term stays the same. I'm changing this to minus 25x and minus 2x
Okay.
because these have to add to minus 27.
Okay.
So now we are going to split. Gonna split this. So this is 5 times 5. This is 5 times 2.
2
This is
X
x. This
and
is
X.
x times x. So the GCF of these first two is they both have
5X.
5 and they both have x, 5x. The leftovers go in parentheses. So that's 2x minus and 5. So that takes care of the first two parentheses. Over here, this is 2 times 1. This is 5 times 1. So bring down this minus sign. So the only number we can use is 1. The 1. So I'm using both of these ones. The leftovers go inside. I see a 2x and minus 5.
5.
Because the minus 1 and the negative 5 that multiplies a positive 5. The twins that we beloved, the beloved twins. Pull them over here. Write those first. 2x minus 5. And
5x plus 5.
is the leftovers
5x. 5x plus 5.
minus 1.
Minus 1.
Oh, minus 1.
Minus 1. That was the other leftover. This one, those are your leftovers there.
Oh, so the 2 minuses will be a plus.
That's right.
Real quick, Professor. So, how did that negative 5? How did that become negative 5 if it was positive
Here,
up top? And
here.
let me. I can't see because I see the Kelly screen.
So
Okay, yeah, right there.
when I multiply this negative with another negative, multiplying two negatives will make this positive up at the top.
Oh, okay. All right. I get it. All right.
We're going to do another one, and we will do it together.
Okay.
Let's see.
This example 14.
Example 14. All righty. Can you all?
No.
Oh, okay. There we go. Now this is a little different because we have a mix of variables. It's still descending order as x to the second, x to the first, and there's like no x's at all here. So that's descending order of the x's. So that's good enough. As long as we have something in descending order, we can do the AC method. So over here, I'm gonna do that on the side. When I multiply AC, I'm multiplying 4 and -5. So
Negative
it's
20
got to multiply to -20,
x squared,
and it's got to add to this. What's this coefficient?
1.
To be exact, -1.
Oh,
-1. So we multiply the first and last, has to multiply to -20, and has to add to this middle coefficient, -1. So let's get our pairs together. 1 times 20, 2 times 10, 4 times 5. So it's going to be this pair.
mm-hmm.
But I gotta what are my
The
signs?
5 going to be negative.
The 5 is negative because when we multiply those, we get -20. And when we subtract those, we
You
get
get
-1.
-1.
So this is our pair. So we write the first 4x squared minus. Now this middle term has the xy, so that's what we're going to use. So we're going to use -4. I'm sorry, positive
Negative.
4xy and -5xy. Because the 4 and the -5 give us the -1. Last term we bring down. So again, this positive 4, -5 gives us this -1.
Mm-hmm.
So we split them up. They both have the number 4. They both have x. What's left over?
X plus y.
Because 4x times x is 4x squared. And 4x times y is 4xy. If you got a minus sign, bring it down. They both have a 5. Do they both have x?
No, they
No.
both have
They
y.
both have a y. Leftovers in parentheses. So if I want -5xy and I have -5y already,
X.
got to put x here.
X.
And
Positive y.
it's going to be positive because a negative times a positive makes this negative. And if I have 5y and I want 5y squared, this has to be a y. Here are the beloved twins. I'm saying beloved because who doesn't love twins? Twins first, and your leftovers is this 4x and this
Minus
negative
5y.
y. So that was a little more involved because you had double letters, but process remains the same. Process remains the same. So that's pretty awesome. So you have homework on this, everyone.
These is cute. I don't mind these.
I'm so happy you said that, Carol, because I feel the same way.
Yeah, these not that bad.
I share your feelings.
Only if all the problems go this easy, but
Right.
it don't work like that.
Right.
Well, I think you will be pleasantly surprised. You will be pleasantly surprised. And I see you tomorrow, Stephanie
Yes, 1 o'clock.
and Brian. If
Yep,
anybody
it's a good
wants,
one.
if anybody wants to do something else, send me a text and we can work it out. Okay?
You said in Zoom, right?
Yeah, same Zoom, the same Zoom link, whatever. Yes.
Okay.
Okay. Have a great evening, everybody.
All right, you too.
You too.
Everyone have a good night.
You too. Good night,
Farewell.
everybody.
Thank you for your diligence. Continued diligence.
Welcome, Professor.
You're welcome.
Mhm.